So today is lesson 3.2 in your algebra book. We're going to be solving equations with tables and graphs. So we've dealt with solving equations algebraically. We've talked about different properties. We used fact triangles. So now we're going to look at the relationship between those equations with tables and graphs and how can we use those to solve them. So the big idea is that tables and graphs lead to exact or approximate solutions to equations. Sometimes we can't get the exact answer on a graph if it falls between a line, but we can approximate what it is. But they also can give us the exact answer. So we're going to be finding the solution of an equation, which is basically just the answer for the variable. Okay, so example number 1, determine if the value of x is a solution for the equation. So we're given the equation 6x plus 42 equals 126. And then we're told x equals 14. So we want to see, is that actually the solution that makes this equation true? If this equation is true, both sides have to be equal because that's what it says. So if I plug in 14, both sides basically need to come out to 126. So back in middle school, this was kind of like running a check. You got your answer of x equals 14. We need to see, does it work? So we're going to start off with our equation. Now, if it was in your book doing your homework, you have to start by writing it. So that's where I'm going to start. But obviously, if it was given to you on a worksheet, you don't have to rewrite the original. But here's what we're starting with. 6x plus 42. We're going to plug in our proposed solution of 14. So x becomes 14. And we're going to test it and see, are both sides actually equal to each other? So we're going to leave the right side alone. There's no math to complete. It's already just a number. We're just going to leave it. We're going to kind of evaluate the left side and then find out if it is also equal to 126. So 6 times 14 is 84. Notice I haven't changed anything else. And 84 plus 42 is 126. And so both sides of my equation come out to the same number, which makes this a true statement, right? These are equal to each other. So determine if the value of x is a solution for the equation. So yes, x equals 14 is a solution. So let's look at one that maybe doesn't work. So here's the equation, 31 equals 11x minus 24. We're going to test out, does x equal 6 in this situation? So I'm going to rewrite it. And now I'm going to plug in my answer. So I'm going to plug 6 in for x. I'm going to leave the 31 alone. So you've got a left side and you have a right side of your equation, the equal sign being your dividing line. If one side is completely simplified, just leave it alone. It's going to continue to just come all the way down. And we're just testing, does the right side come out equal to that side? So 11 times 6, 66. And 66 minus 24 is 42. So I get 31 equals 42. Well, that is not true. 31 does not equal 42. So the answer to the question, determine if the value of x is a solution for the equation, no. X equals 6 is not a solution. So in order for a number to be a solution to an equation, it has to actually make that equation true, meaning both sides are equal. All right, let's slide down to example 2. Can we kind of look at the same idea, but using tables now? So example 2, solve by making a table for each equation. And we're going to circle the row in the table that actually contains the solution. So if you take a look, x and 4x plus 3. 4x plus 3 comes from the left side of this equation. We basically want to find out, when does 4x plus 3 equal 11? What value of x makes this true? So we're going to try out a bunch of different values of x, just making a nice little table of values here. Plugging in those numbers into this expression 4x plus 3, finding their values. And if we can find a value of x that produces 11 as the value of 4x plus 3, we have solved for the equation. So just going to start with the easy number like 0. If I plug in 0, 4 times 0 is 0, plus 3 is 3. So if 0 is the value of x, this expression is equal to 3, not 11. So what about 1? 4 times 1 is 4, plus 3 is 7. So if x is 1, y would be 7, or the value of the expression would be 7, not 11. So what if I plug in 2? 4 times 2 is 8, plus 3 is 11. Take a look. If x is 2, 4 times 2 is 8, plus 3 equals 11. This is the solution. So the solution to this equation is x equals 2. I could finish this off if I plugged in 3. 4 times 3 is 12, plus 3 is 15. Plug in 4. 4 times 4 is 16, plus 3 is 19. Okay, so I think the solution is x equals 2. Let's run a check. So basically what we just did right up above, we're going to start off with our equation, and we're going to show algebraically why this works. Because we didn't really prove anything, we just have a bunch of numbers in the table. It doesn't mean they're right. So let's prove it. Let's plug in our answer that we say x equals 2 is the solution. So if I plug in 2 for this equation, and I solve the left side all the way out, I get 11 equals 11. My check works, so I know my solution is correct. Now, we know how to solve this algebraically. You minus 3 on both sides and you divide by 4. Okay, this is just another way to look at it. So if we slide over to this one, negative 3x plus 5 equals negative 4. We're going to test out a bunch of values for x and see if we can't find one that produces negative 4. So again, I'm going to start with 0 and just kind of run down these numbers. Now, I'm picking basic numbers, and I know specifically because obviously I made the problem that it's going to work. One of these is going to work, but you're not always guaranteed that 0 through 4 is going to work. Sometimes you might have to try some other numbers to get you closer. You kind of have to evaluate how close am I getting with these numbers. Maybe I need to make an adjustment to find the right one. So if I plug in 0, negative 3 times 0 is 0, plus 5 is 5. So I'm trying to get negative 4 for this expression. What value of x when I plug it in for negative 3x plus 5 equals negative 4? So how about 1? If I plug in 1, negative 3 times 1, it's negative 3, plus 5, that's positive 2. Now think about it. I went from 5, pretty far away from negative 4, to 2, closer to negative 4. So I'm going the right direction. So I know if this was going the other direction, if this all of a sudden was, say, 10, then I need to go the other direction. Instead of going up, I need to go down from 0, and then these numbers will go down. But since I am getting closer to the solution that I want, I'm going to keep going. So plug in 2. Negative 3 times 2 is negative 6, plus 5 is negative 1. Still closer. Plug in 3. Negative 3 times 3, it's negative 9, plus 5 is negative 4. That's the one we wanted. And if I did plug in 4, that'd give me negative 12. Okay, plus 5 is negative 7. So your solution is x equals 3. That's the value of x that makes this equation true. It produces negative 4, which is what we saw right here. So let's run a quick check. Prove that our work is correct. So we start off with negative 3x plus 5 equals negative 4. Plug in 3. Show the work that we did. So negative 9 plus 5. And that produces negative 4 equals negative 4. All right, so we kind of worked through plugging in a number to see if it works. Now we tried a bunch of different numbers and we found the one and proved which one works. Now let's see, what does this look like on a graph? And how could we use a graph to do this? So we're going to solve each equation using the graph that is given. Now, what you want to do is you kind of want to come up with a table here, table of values for 3x plus 4 equals 7, and then we're going to put it on the graph. So down here at the bottom, I'm going to make a quick little XY chart, and we're going to use 3x plus 4. So if I plug in 0 for this, and let's actually relabel it instead of y so we don't get confused. Let's just put the expression, but that's going to be the y value when we plot it here. So let's at least keep that around so we understand. So if I plug in 0 to the expression, notice I didn't use the 7. I'm just using the 3x plus 4. Okay, if I plug in 0 to that, I'm going to get 0 when I multiply, plus 4 is 4. If I plug in 1, 3 times 1 is 3, plus 4 is 7. If I plug in 2, 3 times 2 is 6, plus 4 is 10. And that's all I need. I need 3 ordered pairs. So you could think about this as 0, 4, 1, 7, and 2, 10. Okay, those are our ordered pairs that I produced. Just picking random numbers for x, plugging them into this expression. Okay, and now we're going to plot it up on the graph. So if I go to 0, 4, the first number is your x. It's always x comma y. So x and y. So 0 for x means I'm not going left or right. 4 means I go up 4. 1, 2, 3, 4. 1, 7, so I'm going to the right one and then up 7. And then 2, 10. It's going to be right there. And if I drew this line, it's going to look something like that. And I could find these other values over here to be a little more exact. Now looking ahead, again, we're trying to find out when does x equal or produce 7? So you could already kind of find it here in the table, but what does it look like on the graph? Okay, again, this equals y. This is when y equals 7, and we want to know what does x equal. So when y equals 7, what does x equal? So where does y equal 7? If you go to the y-axis, count up 1, 2, 3, 4, 5, 6, 7, and you go over to the line, you will find where this expression, 3x plus 4, equals 7. Where does it equal 7? At x equals 1. So the solution here is x equals 1. Or you can write the ordered pair 1, 7. So either one. And anywhere up here, if you think about it, y equals 7, anywhere on this line right here. So even if I'm over here, the x value has gone down to the negatives, but the y value is still 7. If I go all the way over here into the positives and up, the y value is still 7. So I basically want to find out where does this line cross y equals 7. And then I'm just trying to look, what's the x value? So this point right here is 1, 7. So that is the place that this 3x plus 4 expression equals 7. So let's slide over. Let's make a quick xy chart on this one. So I'm going to put the expression negative 2x plus 4 here. All right, and then again, that's your y value basically. We're trying to find out what's the y value. So let's plug in some numbers. I'm going to start with 0. You plug in 0. Multiply, you get 0 plus 4 is 4. So 0, 4 is right there. Now, if you look, we're trying to get negative 2. Where does y equal negative 2? So we want this number to kind of go down. So let's see what happens. We probably need to plug in some bigger numbers. Let's plug in 1. So negative 2 times 1, that's negative 2, plus 4. Well, that's positive 2. What if I plugged in 2? If I plug in 2, negative 2 times 2 is negative 4, plus 4 is 0. All right, let's put those points on. So 1 and 2 and 2 and 0. Now I want to know where y equals negative 2. So y equals negative 2 is right here. It's anywhere on this line. So if you start to look ahead, I need to know where is this line, if I connected the dots, going to hit y equals negative 2. Anywhere on this line, the y value is negative 2. So if I continued this line, you can kind of, this is called the slope. It's down 2 over 1, down 2 over 1. So down 2 over 1 should put me right here. And you can see it's the next dot in the progression, which means it should be x equals 3, and I can test it out. If I plug in 3, negative 2 times 3 is negative 6, plus 4 is negative 2. And that's the y value that we wanted, was the negative 2. So if I plot this point, 1, 2, 3, negative 2, I can connect all these dots. If you have a straight edge, you can use it. Okay, but this point right here, that's where the y value is negative 2. So the x value is 3. So you can kind of show it like this. So it's hitting the y-axis at negative 2. It's hitting the x-axis at 3. So it's 3, -2, x is equal to 3. That's how you solve the equation. And I could run the algebra there as well, and I could plug it in and show the check. And if I plug in 3, it's going to come out equal on both sides. Okay, but this is how the graph now relates to the equations that we're looking at. All right, one more quick example. If we slide down to the bottom, we're going to write our own equation, and then of course we could solve for it using any of these tools or skills that we just developed. So it says Khalid lives in Alaska. There's no sales tax. He bought 3 tacos with a $5 bill. So he gave them $5 and he got 77 cents in change. So let's think about that for a second. He paid a certain amount of money for the tacos. We don't know how much. Okay, but then he got 77 cents back from his $5. So that means the cost of the tacos plus 77 cents equals $5. So I'm going to start writing that right now. So the cost of the tacos, I'm going to leave blank for a second. But we know that he got back 77 cents. And if I added the cost and the 77 cents, that's going to have to come out to $5. So we're going to define a variable, the thing that we don't know, and then represent the relationship with an equation. So we already started writing the equation here. So we know we bought 3 tacos. So if we knew the price of a taco, we would do 3 times that price. I'm just going to call it X for now. If you wanted to call it T for tacos, definitely makes sense. We need to define the variable, though. Define the variable. And we talked about this all the way back in 7th grade. Defining a variable just means telling the reader, what does your variable represent? So X equals the cost of a taco. Don't just say taco. If you just say X equals tacos, then that could be the number of tacos. But X doesn't represent the number of tacos. If we bought 3 tacos, you don't do 3 times 3. Okay, it's the cost of a taco. Now, it doesn't ask us to solve this, so we're good right now. But if we wanted to, we could put this on a graph. We could make a table. We could plug in numbers until we got something that came out to 5. Okay, that's all going to work. But for now, we just wanted to write this equation. So 3 times the cost of 1 taco will give you the price of 3 tacos plus the 77 cents change that he got has to equal $5 total. So that's how we're going to keep working on building these equations.